My name is Saumya Upadhaya. Thanks, Steve. You pretty much got the pronunciation right. And I'm a product marketing manager at Gitlab. And today we're going to talk about rethinking security within DevOps. So I'm going to turn off my video because I think there was a preference to see the slides full screen. So I hope this is better. So jumping right into it, a senior investor, Mark Andreessen, has a lot of quotes to his attribution. One of the biggest one is, software is eating, software is really eating the world, right? What does it really mean? In the context that we are today in, everybody is trying to pivot to move a lot faster. Developers are creating code like there's no tomorrow. Pretty much 2 billion lines of code are created every single week by developers, right? In the current context, if we look at it in the current economic situation that we are in, because of COVID, companies are trying to move a lot faster. Some examples are, for example, the NHS in UK itself. I read about it that they actually introduced telemedicine in telehealth in 15 days. It was on the back burner for a really long time. And when there was a need, they would actually be able to introduce it in 15 days, right? So developers are moving fast, deployments are moving fast into production. Is security able to catch up? That's what we are going to talk about in today's session. And one of the main reasons developers and deployments are able to move a lot faster is because of the adoption of cloud-native technologies, right? So the inherent nature of cloud-native technologies make enterprises move from a monolith to multiple different microservices. What that means, more iterative development, smaller chunks that can be released into the market. They use the Agile DevOps processes to release these smaller chunks. And there are multiple entry and exit points for these smaller chunks itself, which are actually enabled through API-based communication, right? But what does this mean for a security organization? So it drastically increases the attack surface. So for a monolith, there was probably just 1 or 2 entry points and 1 or 2 exit points, and security pretty much had to secure those entry points and exit points. But now with the whole microservices-based architecture, there are multiple different, there can be tens of hundreds of entry and exit points for a particular application itself. So that means that security needs to catch up and really secure all of these new technologies that are being used by developers to deploy applications into production. And it's really difficult to do this with a tool set that has been built 10 years ago to actually secure this new style of development that that developers are actually using. So let's take a few examples from a security point of view, right? So we hear a lot of concerns from a cloud adoption point of view. Is it really secure, right? So let's take a couple of examples. So Capital One Bank in the US was actually exposed. It was exploited by an employee itself, where they actually used a misconfiguration in one of their application firewalls. Now, this is a human error. This could have been avoided, but what it resulted for Capital One was theft of 100 million customer records. They had to actually spend about $100 to $150 million in actually legal fees, in fixing some of these issues, in communications, customer communications, and so on. And after that, loss of credibility, and their stock took a beating, right? Another example, right? And here again, if you can see, it's for a company called AutoClerk. So they are actually used by a lot of travel companies for flight and hotel reservations. Right? They were using an Elasticsearch database on AWS without securing that Elasticsearch database. This resulted in data being leaked, including government and defense personnel data of all their travel data, both historical as well as upcoming data, all the way until what the check-in, check-out time is for that particular individual, right? So this is a huge compromise in terms of security for an organization. So security is high risk and it's high stakes, but most often, most of these changes, issues are caused by misconfiguration, vulnerable application, human errors, and so on. So what can we do to change the odds, right? We really need to get in there and change it. But what we're seeing is that even basic application security is really hard for a lot of customers, right? So like we discussed, code changes are getting a lot faster. Different newer technologies are being used. Now, if you're using scanning technologies of the earlier years, you will need to do a full application security scanning. That means that it's going to take a long time. It can only be done at the end of the process. It's too much done too late in the cycle, right? Because by the time you actually do it, you don't have the time to actually fix things, and you might need to compromise on what you will fix and what you won't fix. Application security tools in its traditional form are extremely complex for developers, right? So developers are used to simple, agile, iterative tool sets that they are using to deploy applications, build faster and deploy faster, right? But the traditional tools are way too complex for developers to integrate into their existing workflow. So the challenge here really is that we've moved ahead from a development and operations point of view, but security is being left behind, and we're trying to retrofit what we had from an application security point of view into the new new Agile DevOps style methodology. It is pretty much like putting a square peg in a round hole, which is what we want to solve. So in a traditional application security scenario, so what I spoke about so far, right? So a developer builds his code, he or she commits the code, a pipeline runs, deploys the code into a test environment, and then you will have a security come in doing static scans, dynamic scans, and so on. And then the security personnel actually would create a new issue to fix it, or would dismiss an issue. So there are multiple issues with this, which we will talk about in the subsequent. First issue is that security is being done way too late in the cycle, right? So there could be over hundreds of commits that have gone into the code that have gone into the test environment, right? Now, by the time we actually doing a security test, we have to wade through all of these commits, find the ones, the code change that has actually caused the issue, and then find the developer who's actually made the changes, and then request for the fixes. That itself is a challenge. Now, this screen, from a process flow point of view, looks simple, but when a customer is trying to adopt this is really the complexity that they are in, right? So typically the way customers adopt DevOps is they have a pain point. Let's say, for example, source code management is a pain point. So they bring in a tool for that particular pain point. The next pain point they might have is CI/CD. So they might bring in a different tool for that. Pain point could be issue tracking. They might bring in a different tool. So over the years, as customers have tried to fix point problems in their environments to facilitate transformation, they have brought in hundreds of various tools into their environment, which actually adds additional challenges, and more so from a security point of view as well. So when you add security to that whole perspective, so as you're aware, security needs to be done at different stages of the development lifecycle, right? So there is a static test which can be done during the code test point of view. There is the dynamic test, which actually needs a running software that can be done. And then there's the manual and penetration test and so on, right? Traditional security organizations will have various different tools to do each of these tests separately. So what that would mean is, in the previous slide, where you saw that there is this whole complexity of tools that customers have brought into their environment, now you need to integrate all of these point security tools with each of those tools that the customer was using. So the combination of integrations that a typical organization needs to do is really mind-boggling, right? That's where there is a compounding of the issue from a security point of view. So that's the challenge, right? Security happens really too late. So what's really required to be done? The first thing needs to be done is that customers need to test all code changes automatically every time, right? It cannot be left to the end of the cycle. It cannot be done only for mission critical applications. For example, there was a university that actually had all of their student databases. That was their mission critical application. And they had done all kinds of security tests. They were running it frequently on that particular database itself, right? On that particular application using that database. Now, on the same server, they were hosting a public website, which was not really mission critical. It was probably just a form that they were actually using to collect some data and so on. Now, that public website actually provided an entry point for a hacker to get in and expose all of the data that was in the secure mission critical database. So what typical security tools would do and enterprises would do is you would try to secure your mission critical application, much like you're securing a safe, but you would leave a door or a window open for a hacker to come in, right? So that is not acceptable. You need to have security testing to be done on all of your applications. So the breadth of security testing needs to be there. And you need to test every time there is a change to those applications. Test early and test often, right? So if you're leaving security testing to the end of the cycle, there could be hundreds of thousands of commits that have gone into creating the binaries for that test. And you could result in thousands of vulnerabilities at the end of the cycle. Now, you may not have the time to fix all of those, or you may not have budgeted the time. And this is typically what happens in a lot of organizations. So at that point in time, you need to make a compromise, right? So these are the things that we're going to fix. These are the things we're not going to fix. That resulted in, for example, a huge issue with Equifax, where they said that we're not going to fix the Struts vulnerability. We don't have the time for it. Let's leave it. And that resulted in millions of customer data being exposed, right? So don't let that happen to you. And you need to deal with security issues as soon as they happen, right? So every time, in typical software development terminologies, every time you leave a bug to move from one phase of the development to the other, the cost of fixing it increases almost 6 to 10 times, right? So if you're leaving a security bug, it's similar. So what would happen is, towards the end of the cycle, the security team needs to then start chasing after multiple different developers. First, identify which developer has introduced a vulnerability, which itself will be a problem because you're using so many different tools for managing your DevOps lifecycle. And then once you identify that, you need to find the developer. The developer might have context switched into a different job altogether. So, the time that you're going to be wasting in trying to get that fixed would be significantly higher than if the developer had found the issue when he was developing it and fixed it right there. So what's actually required? What's the ideal scenario? What's Utopia, right? So as soon as a developer has checked in a code, the application security would need to happen in the pipeline itself, right when the rest of the testing is happening, so that in the context of the developer gets identifies the defects in his code, in his or her code. They also identify the security defects at the same time, right? So at the same time, they can go ahead and decide to fix it, or they can decide to close it. That's the ideal scenario, rather than having it at the end of the cycle. So what are the different types of security products that are required? So you would need the general static and dynamic application testing. Increased use of cloud-native applications means container scanning to make sure that no vulnerabilities are introduced. Also, dependency scanning. These days, a lot of organizations are using multiple different open source products which are dependent on each other. So by introducing some of those dependent open source products, there needs to be a test to make sure that the dependent product is not introducing a vulnerability. License compliance. Your organization might have certain rules about which licenses are okay for your organizations to use and which are not. So the compliance measures need to be captured as well. So all of this needs to be integrated into the developer's pipeline so that when the developer receives feedback right when they're actually testing, right? So what does it look like? So this is really a pipeline. So you can see there's a build phase, there's a test phase. So along with the code quality and the unit system tests that a developer would be performing, they would also have the security test, the container scanning, dependency scanning, license compliance, static analysis. Now, dynamic analysis requires a running software, right? So we'll talk about it in a little bit, but we actually create a running software through the pipeline itself, where we create a review app, which can then run the dynamic tests as well. So all of your security related tests can be done as a part of the developer's pipeline itself. So what does the new workflow look like, right? So the aim is to really enable the developers to resolve security vulnerabilities as well as a part of their process itself, and then only allow the security team to work on exceptions. This also aligns well with the strength of employees that are there in an organization between developer to security team, right? So there are tons of more developers than there are security personnel, which are difficult to find, difficult to fill positions as well from a security team point of view. So you need to start shifting left and enabling the developers to identify the vulnerabilities, fix the vulnerabilities faster, and then make the security team more from an oversight, influence, enforcement point of view as well. So a developer in this workflow would choose to dismiss an issue or fix the issue. Now, if they dismiss the issue, it is a concern for the security team, but that does not go unnoticed. So the security team can actually needs to get a dashboard which actually shows what are the vulnerabilities that the developer actually dismissed, so that the security team can then, by exception, go and figure out if that needs to be fixed or not. So here, if a vulnerability was already detected and fixed, those do not even come to the security team. So the workload for the security team itself goes down significantly. What's the advantage of such an approach? So it is similar to probably using a mobile phone camera compared to an SLR camera, right? So SLR camera is great. You can use it for getting high definition photos, very specific use cases. If you, for example, if you go on a safari, you probably will not get pictures of an animal without a telephoto lens, right? So for those, you probably need an SLR camera. But in most cases, you actually can do with your mobile phone camera. It's simple, it's easy. You can share photos in context with your family and friends, similar to including security testing as a part of your DevOps workflow itself, because in the context, the developer can go ahead and fix it as a part of their DevOps processes. It is integrated into their development tools itself, and it is automated. Right, so GitLab application security testing, the goal that we have is to empower the developer to support the security as required. So I'm going to quickly run through some of these slides and jump to the last slide in the interest of time. So we detect the vulnerabilities in the pipeline itself. For each of the vulnerabilities, we give details even up to the level of which line of code there is an issue. The developer can choose to dismiss the vulnerability or fix the vulnerability, and the security team and the CISOs can actually get a high-level view on what the exposure is from a security point of view. Are there specific areas that there needs to be, we need to provide attention. One of the key areas we are working on is auto-remediation or suggested remediation. So based on a research done by CSO Online, 60% of the breaches happen when a patch is available but not applied on the application, right? So one of the things we are trying to work on is, as soon as a vulnerability is detected, we can actually go and check whether there is a solution for it. It could be an upgrade, it could be a patch, whatever, and suggest that to the developer. And the developer has a choice to apply it automatically it creates a new pipeline, and the security testing can be done. So this is automated so that the developer doesn't have to spend too much time on security itself. So GitLab actually is, so we've spoken so much about the breadth of the things that we do, but we also do depth. For example, GitLab is a leader in continuous integration. As per Forrester, when we integrate security as well as a part of this process, it makes it even more powerful, right? So, but application security is so much more than scanning. So based on a research done by ESG Research, security has, these are the top 5 challenges that security personnel actually face. And the solution really is to automate, test more, test early, test often, and make it frictionless so that developers can actually go ahead and fix it. So this is my last slide. So GitLab enables compliance without friction. So it's not just about scanning. We also enable compliance for a customer. It's a single application, single data store. So all the data is actually available in our data store. We help customers to enforce segregation of duty, access controls, and so on. We're also a secure application. Our SaaS service is SOC 2 Type 1 compliant, and we are actually currently pursuing the Type 2 compliance as well. And we provide a lot of controls that customers actually require to enforce their security and compliance needs. To end with, we need to adapt. Security is all about adapting for resilience. So basic security hygiene needs to be done. You cannot leave passwords clear. You cannot leave firewalls open and so on. So basic hygiene. So the security tests need to capture those in an automated format. There needs to be monitoring, detection, and response back into the feedback loop should be there. And then there should be policy automation for compliance as well. With that, I will end my presentation. Over to you, Steve.